Hello again, and welcome to the first video for DMA 10 Section 6, Exponents and the Order of Operations. In this video, we're going to cover the exponent rules, the order of operations, and then look at some practice problems. In our next video for Section 6, we're going to look at some advanced practice problems and some applications and word problems for the order of operations as well. Let's start with the definition of an exponent. An exponent is used to indicate repeated multiplication. It tells how many times the base, which is the big number, is used as a factor. So in this first example here, our base is going to be 5, so this is the number that's going to be repeated. And then our exponent, the small superscript up top, is how many times we're going to repeat this 5, okay? And we're going to multiply every single time. So this says 5 to the second power, or for the second power we might say 5 squared. Okay, 5 squared, or 5 to the second power, is 5 twice. So 5 times 5, and 5 times 5 is 25. For our next example, we've got 9 to the third power, or for the third power we sometimes say cubed. 9 cubed is 9 3 times. 9 times 9 times 9. Okay, starting at the left, 9 times 9 is 81 times 9. And then when we multiply 81 times 9, we get 729. So that's a review of exponent rules. Now let's look at using exponents with negative numbers. We have the same digits here, 3 cubed, or 3 to the third power, but notice some things here. Here we have a negative 3 with the negative inside the set of parentheses. That's very important. In our second example, we have a 3, but with a negative outside the parentheses. And then we have a negative 3 with no parentheses. So let's see how this changes as we move over from time to time. Okay, let's start with the first example, negative 3 cubed. Since the negative is inside the parentheses with the exponent outside it, we're going to repeat the negative each time we repeat negative 3. So this is going to look like negative 3 times negative 3 times a third negative 3. Negative 3 3 times. See, the negative got carried each and every time we repeated the 3 since it was inside. First, we'll multiply these two. Negative 3 times negative 3 gives us a positive 9 times another negative 3. Okay. And then a positive 9 times a negative 3 will give us a negative 27. Now, let's look at negative 3 to the third power with a parenthesis on the outside. Here, what we're repeating is just what's inside the parentheses. Okay, is 3. So we're going to carry over the 3 times 3 times 3. Okay, and this negative gets carried over only once. Okay, so we have a negative 3 times 3 times 3 times 3. Okay. So we'll start here. Negative 3 times a positive 3 will give us a negative 9 times another 3. Okay. Then times negative 9 times 3 is going to give us a negative 27. Okay. And lastly, negative 3 cubed with no parentheses is identical really to the problem that we saw before. We're going to carry over this negative sign and just expand positive 3's. Okay, and again we'll get negative 27 when we do that. So the only time that we carry the negative sign inside is when it starts inside the parentheses. Otherwise we just bring one negative sign over. Okay, and a way that I was told to help remember this is think of your negative sign as ketchup on a hamburger. If you want ketchup on your hamburger, you want it on your hamburger every time. So we're going to keep it on there every time. If you want your ketchup on the side, okay, you just have it on the side and there's never any ketchup on your hamburger. So that negative sign is like ketchup in that example. going to show you two special rules for exponents. Anything to the first power, like this, 6 to the first power, is just 6 one time, or 6 is repeated once, so it is itself. And anything to the 0 power, it doesn't matter what number it is, but anything that is raised to the 0 power is 1. That's something that you're going to have to memorize. Some people might think, oh, it's 6 0 times, so that's 0. But mathematically, that's not really correct. Anything to the 0 power is going to be the number 1. Now let's look at the order of operations. The order of operations is the hierarchy, or the order in which we perform equations or problems with multiple operations in them. The first thing that we always want to do is going to be to do parentheses. Let's see what parentheses look like. We've seen parentheses like this in some of the previous videos with maybe some operations inside. We've also seen brackets in our videos. Those are considered parentheses. Some other things you might see these curly braces. Okay. Those are sometimes used to set things apart in an equation. Not too often in this class, but you may see them from time to time. Or the absolute value bars. Okay, so if we had 2 minus 3, say, in the absolute value bars, we would consider that a grouping of parentheses. All of those things would be considered in the parentheses step. The second step after we've completed everything in the parentheses is going to be exponents. So things like 2 to the second power, 5 cubed, or 5 to the third power, 1 to the fourth power, or even, we won't see these just yet, but later on, square roots. So the square root of 4 maybe, are considered in the exponent step. Next, we multiply and divide from left to right. Notice that multiplication and division are not separate steps in the order of operations. They're of equal importance. They're on that same level of the hierarchy. So we multiply and divide starting on the left and then work our way over to the right. And that's really important. A lot of people say, oh, well, multiply is first in the list, so I have to do all multiplication before I do any division, and that's not true. We always multiply and divide from left to right. We could have, something like 2 times 3 like this. We could have 2 times 3 like this. Those are different ways to show multiplication. 2 divided by 3 for division, or even, let's say, 4 divided by 2 written as division that way. So those are things that we're going to see with adding and subtracting, or multiplying and dividing. And last but not least, adding and subtracting. Again, just like multiplication and division, these are not separate steps in the order of operations. They're on that same level of hierarchy, and we're always going to work from left to right. So whenever we do adding and subtracting, do the leftmost operation first, and then move over. Here are some different tricks to help you remember the order of operations. Some mnemonic devices and the like. The first is, please excuse my dear Aunt Sally. The first letter in each of these words stands for a different order, or different step in the order of operations. So parentheses, exponents, multiply and divide, add and subtract. Please excuse my dear Aunt Sally. Another way people remember this is as the word PEMDAS. You can remember the word PEMDAS. And I always encourage my students to write order of operations like this. It shows that each of these is a different level of that hierarchy. So parentheses first, you have to do everything on the parentheses before you can move down to exponents, and you do everything there. Multiplying and dividing from left to right, that little arrow helps us remember that. And then adding and subtracting from left to right. That makes sure that multiplying and dividing and adding and subtracting stay on the same level of our hierarchy. We can't move down until we've done everything above that step. Alright, time for some sample problems. Just to remind ourselves, I'm going to write that abbreviated version of the order of operations over here. So we have that to remember. So let's look at this first problem. We have 24 divided by 6 times 2. Okay, there are no parentheses, so we can move down to exponents. No exponents in this problem, but we do have multiplication and division, so that's where we'll start. That's all we have is multiplication and division. So Remember what I said before. Don't think that just because the m comes first in PEMDAS that we have to do this multiplication first. We're actually going to work from left to right. So the leftmost operation is going to be this 24 divided by 6. So we're going to do that first. 24 divided by 6 is 4. And then we're going to carry down the times 2 that we didn't use. So now we have 4 times 2 as our last operation. And that's going to be 8. Our next equation, or our next example, is 3 times 2 to the third power minus 4. So looking over at our order of operations, there's no parentheses to do, so the first thing that we're going to do is our exponent, 2 to the third power, right here. I'm going to do that off to the side just so we can get a little bit more practice with exponents. 2 to the third power is going to be 2 times 2 times 2, that's 2 3 times. 2 times 2 is 4 times 2, and 4 times 2 is 8. So we're going to replace that 2 to the third power with 8. So now we have 3 times 8 minus 4. And we finished all our exponents, so we're going to move down to our next step of the order of operations, multiplying and dividing. We do have some multiplication there. We've got the 3 times 8. So we'll do that. 3 times 8 is 24. And then carry down that minus 4 that we didn't use. And our last step is going to be subtraction. 24 minus 4, or 20. Now, see how I worked these problems vertically, lined everything up nice and neat, and worked down as I went from step to step to step. I really encourage you to do that. Keeps your work nice and neat. It helps you know where you are in the problem and prevents you from getting lost. So if you have to do scratch work, it's okay to do it over to the side over here, like I did. But make sure once you get that answer, you keep plugging it back into the equation and move straight down this nice orderly list to help keep yourself on track. One more example for order of operations practice. Again, let's go ahead and remind ourselves of the order of operations on the side. So, the first operation, the first step on the right here, parentheses. We do have something in parentheses here. Negative 8 minus 3. So we're going to have to do that first. Let's talk about the other things that are going on in this problem where there's some exponents over here. We have an addition step. Remember, this 2 on the outside is going to be implied multiplication. I'm going to go ahead and draw a times sign in there so I don't forget that that's 2 times whatever I get in those parentheses. And I've got the subtraction in the parentheses. So this may seem weird and counterintuitive. Subtraction is the last thing on the list, but it's the first thing we're doing. But we're doing that because it's in the set of parentheses here. So negative 8 minus 3. The signs there are the same. So we're going to add these two numbers and keep the sign. We get negative 11. Okay? Still times 2, and then plus that 5 cubed. Okay, so we'll look back on the right. We did all our parentheses. Check. Next thing that we have to do is exponents, and we do have exponents. I'm going to do some scratch work over here on the side. 5 cubed. I think we did this earlier. That's 5 times 5 times 5. 5 times 5 is 25 times another 5, which is 125. So, 5 cubed, we said, was 125 plus 2 times that negative 11. Okay, so all our exponents are done. Check. Do we have any multiplication and division? We sure do. 2 times a positive 2. Remember, a positive 2 times a negative 11. Now, watch what happens to this positive sign here. We've got a positive times a negative, so we're going to get a negative answer. So this is no longer going to be addition, but a subtraction, because the sign of the answer from this multiplication step is negative. So let's do that. Positive 2 times a negative 11 is a negative 22. Okay? And then we bring down the positive 125 that we didn't use. So the operation here in the middle comes from the sign of the answer in this step. Okay, now we're ready to finish it off. Multiplication and division is done, and we can add and subtract. We have 122 minus 22, and when we subtract those, we get 103. That's going to be positive. That's our final answer. So to review, in this video we just went over the exponent rules. We talked about the order of operations and ways to remember them, and then we did some practice problems. In the next video we're going to do some advanced practice with order of operations, where we'll see several different operations involved, and then do some application and word problems as well.